Good morning, everybody. This is Massimo Leone from University of Turin, Italy, cooperating with Korea University and with K-Club Open Seminar. Today, we're going to talk about the voice of artificial intelligence. Let's go through the introduction. First, we're going to talk about the voice in the era of artificial intelligence. It is a paradigm shift. Synthetic voice technologies are moving from experimental tools to everyday infrastructures. AI voice systems no longer reproduce sound mechanically. They model context, emotion, and discourse intention. Voice becomes now separable from the body, from identity and presence. So we face emergence of voice as data. Voice becomes something that can be trained, transferred, and reproduced. It is a semiotic resource that can be displaced. So what is the key question there? The key question is what happens when vocal presence is no longer tied to a speaker? Let me pose for an example. In Italy as well as in Korea, we have interphones. So when you try to get in your home because you have forgotten your keys, you ring the interphone, and if your wife, your husband replies, "Who's that?" And normally in Italy, you reply, "It's me." Well, of course, that "it's me" could be said by anyone, and your wife, your husband recognizes you and opens the door because he or she recognizes your voice. So the voice is linked to the body, is linked to presence, is linked to identity. But what if we can now clone a voice as we please, where, well, we couldn't say anymore, "It's me" at the interphone, because anyone could clone our voice and try to access our house through a cloned voice of ours. So let's now talk today straight to the point of the passage from speech to simulation. New models, for instance, a very famous algorithm in the West is called 11 Labs, generate highly realistic voices using limited training data. AI voices modulate tone according to context. For instance, they can change according to news, literature, conversation, but they can also reproduce and simulate human markers, so hesitation, rhythm, affect. As I'm speaking to you, although I'm a trained professor, there are always some markers of hesitation, and I make some mistakes, although I can control my speech pretty well, but professors usually do this as well. So we can reproduce these mechanically, and the voice as a consequence becomes an algorithmic construction of vocal identity that reproduces even imperfections and hesitations. So there is a shift from recording speech to synthesizing communicative intention. There are, of course, also opportunities and not only risks in artificial intelligence, and the main opportunity is an expansion of vocal agency. First of all, in terms of accessibility, speech preservation for patients losing vocal abilities, for instance, or instant multilingual dubbing, preserving vocal identity. In Italy, we dub all the movies. We love Korean movies and we dub them in Italian. So now with artificial intelligence, we might reproduce the same voice of Korean actors speaking Italian with their tone of voice, with their particular beautiful voice. But also the production of audiobooks, media production, interactive storytelling are becoming possible with the production of AI voices. I constantly listen to podcasts and to audio newspapers that are read now to me not by actors and actresses, but by beautiful voices produced with artificial intelligence. We can also produce new interfaces for human-machine communication, and that is actually leading toward frictionless translation and global voice interoperability. So very soon I won't have any troubles visiting Korea because a software will translate my voice into Korean, and Korean voices will be translated into English or Italian. So, what are the risks of this new technology? Well, of course, deep fakes and semiotic instability. Voice cloning enables impersonation and political manipulation. We know already these risks about the face, the deep fakes, but these risks are evident also in relation to the voice. And there is also a breakdown of voice as evidence of presence or authenticity. Remember the example of the interphone. I won't be able to say anymore, it's me, because my voice it will be a semiotic resource that someone can clone also in order to fraud my family. So, for instance, in Italy now, they are suggesting elderly people to have a code so that if they receive a hurried phone call from their children, and their children say, "Oh, well, Dad, I have to pay this fine. Please send me money." They have to ask first, "Yeah, but what is the secret code that we have decided beforehand?" Because that voice might be cloned, it might be a fraud. So the other risk is the emergence of a reality apathy, so uncertainty about what is real, because the low cost and high accessibility will increase also misuse potential of these AI voices. And there's going to be an ongoing arms race between generation and detection. We're going to use AI to fake voices, and then we're going to use AI to detect faked voices. So, what are the semiotic implications of these tendencies? A voice will go beyond the human. It will shift from index of embodiment to programmable sign. Here the reference is to Charles Sanders Peirce, who was a semiotician, a philosopher, US philosopher, who would say that signs sometimes have this property called indexicality, like fire that produces smoke, and smoke becomes a sign of fire exactly because it has been caused by it. So the voice was an indexical sign of our body and our presence, because our body would produce that voice, but that is not longer a completely truthful, because we can produce the same voice without our body. So what will happen is a separation of speaker, voice, and agency, which will transform communication ethics. And we will witness probably hybrid ecosystems, machines speaking to machines and humans. So the voice will become part of a platform economy, a sort of a gigification of vocal identity. And the future challenge will be to redefine trust, authenticity, and presence in vocal communication. Let's go now to part number 2, which is specifically about the social effects of AI voices. So, on the one hand, we're going to see a democratization of vocal simulation. So, vocal and voice cloning shifts from specialized studios to consumer level tools. So now everybody can clone his or her voice, everybody can clone the voice of other people. It doesn't require a complex laboratory, it can be done and performed with a cell phone. So low economic and technical barriers, of course, expand participation. And what happens is an emergence of distributed vocal production. So journalists, creators, institutions, they all rely on AI voices for their products, for their production. So the voice becomes a scalable communicative interface rather than a singular performance. So there is a sort of a voice industry, AI voice industry that comes about. And hybrid media ecologies go towards the new definition of the voice as a plugin. So voice AI integrates with text generators, image synthesis, and video production. So there is a whole synergy of these systems. And that allows the production of a multi-platform identity. So audio, video, newsletters, social feeds are produced together by artificial intelligence. And the automation of personal reproduction across media environments is becoming a reality. So I can produce an avatar of myself, an AI avatar, with my face, with my voice, and have this avatar perform across media environments with an increasing blending of human and synthetic vocal output. So we do not only have human voices and AI voices, we have a continuous blend of human and AI. So I can be, for instance, a famous actor or a famous politician and speak to some events with my own voice, but in some other events in which I don't know the language or I cannot attend or it's too risky to attend, I can communicate with my own voice, but in its cloned version. So this, of course, entails also some dangers, which are those of strategic manipulation and micro-targeting. We don't realize how powerful our voice is. Our voice can hypnotize, our voice can convince, our voice can transmit emotions, but above all, our voice can transmit trust and confidence. So, synthetic voices enable localized persuasion rather than mass propaganda. Of course, also the great dictators of the past, like Mussolini, like Hitler, would rely on the voices to address the masses. But now we are talking about a voice that can be synthetically produced in order to micro-target the addressees of propaganda, in order to convey hyper-personalized messaging that increase plausibility and emotional impact. So one likely scenario is election interference. For instance, in democratic elections, we might have interference by agents that spread messages through synthetic AI voices that are targeted to specific voters. So this is an example of small scale but high impact use of AI voices. And it's going to be, as a consequence, a semiotic shift from broadcast persuasion to tailored vocal encounters. So what will be the semiotics of trust after voice? Well, the traditional assumption that voice is an index of presence and authenticity will be shaken because AI, artificial intelligence, transforms voice into a symbolic construct detached from embodiment. So the verification moves from perception, I hear a voice, I trust a voice because I recognize its sound, so it sounds real, to external protocols on metadata, watermarking. So we cannot trust our perception anymore. We must ask technology and more artificial intelligence to check on artificial intelligence. We have to trust artificial intelligence to verify voices produced by artificial intelligence. So trust becomes procedural, a procedure instead than perceptual, a perception. I don't trust what I see. I don't trust what I hear. I trust what AI sees and hears. And this will, of course, bring about disorientation as a new condition of communication. You see these spaces and these bodies, Lorna Alvarado, Juliana Silva, Isabel Mercado, up to maybe 10 years ago, I would be completely sure that this person would exist somewhere in the world. Maybe they had fake names, maybe they had fake credentials, but they didn't have fake bodies or fake faces. Now these faces, these bodies, but also these moving bodies and their voices can be synthetically produced. So this shows that AI applied to the body and in particular to the face, but also to the voice, will bring about a coexistence of opportunity and risk, producing epistemic instability. What does it mean, epistemic instability? That we won't be so sure anymore in the future about whether a voice is human or machinic, about whether a voice is really attached to a body, about whether someone has really said something or used his or her voice in a certain way, or if it is just a fake produced by artificial intelligence. So users will more and more and are more and more navigating an environment where provenance isn't certain, but communication continues. So there's not going to be, of course, a total collapse of reality, but continuous ambiguity about ownership. So the future challenge will be redefining presence, responsibility, and also vocal agency. So what we can do, what we can perform with our voices in an AI-mediated communication environment. Let's go to part 3 now, and we're going to talk specifically about AI vocal identities. So what we observe in a voice is mainly some aspects that go beyond the semantics of language. So language has a semantics, has a meaning, but when we speak with our voice, we attach our own personality to that meaning. So voice is also physical, material. It is a sound that has a pronunciation, and that also entails a recognition. So in order to make a voice human, we have to simulate all the physical traits of a voice. So new voice models demonstrate improved pronunciation of diverse names. I remember how the robotic voices would be in the past. We would immediately realize that the voice was not human, it was artificially produced, it was robotic. Trains were announced by robotic voices, but it wasn't so pleasant. Now we have perfect human voices produced by artificial intelligence, because synthesis is context aware. So speech synthesis is aware now of the semantic context in which a voice speaks. It reduces mispronunciation errors that were common in earlier assistants. So this correct naming, this correct pronunciation produces also effective recognition being seen through technology. So our technology is able to speak our language, speak our dialect, to pronounce our names correctly. And this voice accuracy becomes also a micro politics of inclusion in environments in which our voice is used also as a mark of identity. So we feel that the voice, artificial voice, is not only true but also inclusive, because it includes our language, our inflection, it pronounces our name, and so on and so forth. But this shift is enabled by the fact that as I suggested earlier, we're going from a scripted speech of robotic voices to contextual understanding. So earlier assistants, vocal assistants, including, for instance, the early versions of Alexa, would rely on phonetic rules and limited data sets. So this is the beginning of computational linguistics, the beginning of computational phonetics. But the new models are trained on massive audio corpora and are unable to detect patterns of pitch, rhythm, and linguistic context. So language agnostic architectures, so what does it mean, language agnostic architectures? It means that it doesn't matter what the language is, it doesn't matter what the meaning is, it doesn't matter what the text is, because these architectures adapt across cultures and accents. And so there is a transition from rule-based speech to probabilistic vocal intelligence. Artificial voices do not work so differently from LLMs, large language models. They probabilistically construct voices exactly as LLMs stochastically construct texts and answers to our prompts. What is crossing the uncanny valley of voice? The concept of uncanny valley that was elaborated in the 1980s to designate by a Japanese scholar to designate the strange effect of this quietness that we feel when we are in front of a video game, for instance, that reproduces the human face in a very realistic, hyper-realistic way, and still we perceive as humans that that face is not a human face that has been constructed. So there is a feeling of uncanny, of not being at home with that face. So in the previous generation, voices would be human-like but slightly wrong. There was a persistent alienation. We would hear those voices, we would listen to them, and at the same time, these voices would not really sound human, sound familiar, sound friendly to us. Now, deep learning enables more natural prosody, emotional inflection, and timing. So, voice AI increasingly indistinguishable in everyday listening conditions. And what are the semiotic consequences? There is an erosion of perceptual cues distinguishing human from synthetic. On the one hand, AI voices are more and more human, more and more realistic. On the other hand, cues to understand whether these voices are human or not, cues, signs, indexes that would tell us about the humanity of a voice are less and less perceptible. And this generates both inclusion and bias, which is a double paradoxical movement. On the one hand, there is improved pronunciation that reduces digital marginalization for non-dominant linguistic identities. What does it mean? It means that in the past, these robotic voices would mainly work in English, and also artificial intelligence would work mainly in English, and English was the main language of technology and also of artificial intelligence. But now all languages and all sounds and phonologies of different languages can be included in this system. We can create voices of rare Amazonian languages, for instance. And simultaneously, at the same time, biases persist. For instance, there are still recognition disparities across accents and demographics, and this is obvious because the data sets that we use in order to produce and recognize voices are still pretty much imbalanced. So AI voice becomes both a detective and reproducer of cultural hierarchies, and there is this double paradoxical movement between inclusion and marginalization that both take place in artificial intelligence applied to the production of voices. This is something that has to do with the ambivalence of recognition. So, accurate vocal reproduction enhances personalization and intimacy. One thing is to have a neutral, aseptic, impersonal voice speaking to me. Another thing is to have the voice of my wife, the voice of my husband, or like some experimental AI artists have explored. I can now have a clone of my own voice talking to me in my headphones, motivating me, for instance, go Massimo, go finish this lecture well. I can have my own voice now in my headphones inside me, encouraging me to a certain task. So the same realism increases effectiveness of impersonation in scams. So it's always a double edge. On the one hand, we have more and more performing voices, AI voices. On the other hand, these voices become more and more effective in the production of frauds and scams. So familiarity becomes itself a commodity, becomes a semiotic resource, and becomes exploitable. Correct naming enhances the trust signals. So here's the paradox: the more human the voice sounds, the less able we become to treat it as evidence of presence. So AI voice becomes more human, but the human voice becomes less a sign and an index of presence. So here we have a little exercise. You can pause this video if you want for, I don't know, 5 minutes, 10 minutes. And the exercise consists in describing your own voice. And you'll see how difficult it is. You see how difficult it is to put into words, put into verbal language, the quality of your voice. It is extremely difficult. So if you want to pause the video for 5 minutes, for 10 minutes, and do this exercise, and then we'll start again this presentation. Because now we're going to talk about technicalities, the vocal latent space. You know what a latent space is the space, topological space in which vectors that create meaning in large language models are organized. And latent space is used also for modeling speech representation. For instance, the best algorithm available, at least in the West, for the creation of AI voices is 11 Labs, and 11 Labs relies on high-dimensional latent representations to encode speech characteristics beyond raw audio signals. So these latent spaces capture semantic, acoustic, and stylistic features simultaneously. This latent space relies on latent embedding. So this latent embedding is a compressed numerical vector that encodes complex properties of speech, such as tone, rhythm, and timbre. It relies on disentangled representation learning, so a training strategy where different attributes, for instance, linguistic content or speaker identity, are separated into independent dimensions. And then conditional generation, so a model output which is guided by auxiliary inputs such as speaker embedding or style parameters. So this abstraction allows flexible manipulation of speech attributes without directly modifying waveform data. You must know, well, probably there are some computer scientists listening to this talk. So I'm not a computer scientist, I'm a mathematician, I'm a social scientist, but what I perfectly understand and what is becoming more and more common sense and common knowledge is that everything that is treated by artificial intelligence is digital, and everything that is digital, it must be expressed as a numeric value. So in order to detect a voice, but also in order to clone or reproduce a voice, so we must turn that voice into a series of figures, into a series of numbers. This is why we have to decompose a voice into different lines, and these lines must be parametrized and vectorialized in the latent space so that each voice corresponds to a network of parameters in this latent space. And this allows us to create this waveform. So it's an acoustic form that corresponds to a voice, but also it allows us to then bend and move this voice around without it to lose its vocal identity, because this is the main difficult computer science task, which is also a mathematical task if you want. So we have to have a voice that we can stretch, we can bend, because it has to ask questions, it has to exclamate, it has to suffer, it has to rejoice, it has to express emotions, it has to express hesitation. But throughout all these transformations, it has to be identifiable as one voice. It's not, for instance, that, like I have my own voice, and when I become sad, my voice is not recognizable anymore. No, it is always my voice, but it's a sad version of my voice. So, what technically enables this process are mechanisms of attention called transformer attention mechanisms that enable speech synthesis. So the core acoustic model of Leone Labs, for instance, employs transformer architectures that entail self-attention. So self-attention is a mechanism that allows each element in a sequence to dynamically weigh the importance of other elements, capturing long-range dependencies. If you use ChatGPT, if you use Gemini, if you use Claude, if you use DeepSeek or other LLMs, you'll have realized that they construct their text word by word in a sequence, because each word is a result of the network of probabilities that link that word to previous word. That's why the construction of text, but also the construction of meaning in LLMs, happens as a probabilistic chain. The same goes for voices. So voices are produced as a probabilistic chain. But in this production, this probabilistic, this stochastic production of voices, also mechanisms of multi-head attention are present. These are a parallel attention operations that learn different relational patterns simultaneously, because a voice is not a text, it is a complex artifact, it is a complex phenomenon that has different dimensions into it. So multi-head attention allows the algorithm to give parallel attention to all these dimensions, and so that positional encoding is possible. So it is possible to add numerical signals to tokens so that the model understands the sequence order. So this mechanism enable a coherent prosody modeling across long sentences and maintain contextual consistency in generated speech. You remember how artificial voices would sound in the past, so they would be able to pronounce a word correctly, but already if they had to pronounce a phrase or a sentence, we would understand that the voice was robotic. There would be strange intonations, strange incoherencies, strange hesitations. Now we can pronounce, we can have AI voices pronounce correctly without hesitation in a phonetically coherent way, not only words, not only sentences, not only paragraphs, but entire long text. So we can have the clone of the voice of a famous actor, Tom Cruise, reading War and Peace from the beginning to the end with this property of maintaining a phonetic arc coherently throughout the entire AI voice production. And this is something that goes under the name of prosody modeling, which is coupled with expressive control. So prosody prediction models regulate temporal and expressive aspects of speech. So they regulate prosody, rhythm, intonation, stress, and timing patterns in speech. But also they contain some predictors of duration. So a neural model that estimates how long each phoneme should be spoken. And these also sorry, there was a little break because my daughter called me. she just awoke. She's 2 years and a half. So we were talking about prosody modeling and expressive control. These models enable a prediction of prosody, and also they allow a regulation of temporal and expressive aspects of speech. We can now model in this probabilistic, stochastic way prosody, so rhythm, intonation, stress, timing patterns in speech. We can have a prediction of duration, so a neural module estimating how long each phoneme should be spoken. You maybe remember some vocal assistants of the past that would pronounce in Italian, for instance, they would pronounce some vowels as too long or too short, and of course, when we pronounce a word in Italian, for instance, if you pronounce my name Massimo, you have to pronounce each vowel with the correct duration in order for it to be a realistic pronunciation. You shouldn't pronounce it Massimo, or you shouldn't pronounce it Massimo. You should pronounce it Massimo. And also pitch contour modeling, so a representation of how pitch changes over time. We are introducing more and more elements in this digital creation of AI voices. My voice, as I talk to you, is changing because I'm getting tired. But not exactly after 30 minutes. But if I give classes, my classes in my university in Turin are sometimes very long, even 3 hours. And after 2 hours and a half of speaking, of course, my voice changes because the voice is a linguistic basis that comes from a physiological substratum. It's something that is affected by fatigue, exactly like our muscles or our brain. So we can introduce a simulation of fatigue in artificial voices now. So we can embed style and also other very peculiar and personalized tokens, so that learned vectors represent emotional or expressive speaking styles. And these turns AI voices into a network of user-adjustable parameters that influence sampling variability, balancing expressivity with stability. We can have a voice that is stable and recognizable across time, but at the same time, it is something that we can modulate, because this is the tricky task with AI voices. The voice must be recognizable all the time, but at the same time, it must be transformable all the time. So speaker embeddings and voice identity encoding are based on particular forms of extraction. Speaker encoder, a neural network that converts audio samples into a numerical identity vector. As I told you before, everything in the creation of artificial intelligence must take a numeric form. So a speaker encoder is a neural network that converts these audio samples into numerical identity vector. But also an embedding space, a multidimensional mathematical space where similar voices cluster close together. And then there is also a particular aspect that is present, for instance, in the AI voice software and algorithms of next and the last generation, which is the zero-shot cloning. So it is a property of this cloning, thanks to which generating speech in a new voice is possible without extensive retraining using minimal reference audio. So in the past, we would need a huge amount of vocal recordings in order to produce the clone of a voice. Now we can clone a voice with a few minutes of recording. And this allows also cross-lingual transfer, so the ability to synthesize the same voice across multiple languages. So this variation includes the fact that now I can have my own voice speak Korean with a certain Korean accent, but remaining nevertheless my own personal voice. So this has been possible because throughout the evolution of AI voices, we were separating, we have been able to separate more and more features that characterize the voice of the speaker from linguistic content. Now there are two separate streams. On the one hand, we can reproduce semantic content through LLMs. On the other hand, we can have whatever voice pronouncing the expressive representation of the semantic contents. And so, what is enabling this is AI producing devices which are called neural vocoders. What are neural vocoders? After this acoustic modeling, neural vocoders generate raw audio waveforms, because we do not only need to turn a voice into a network of numerical parameters and vectors, so we need then to pass from this network to the production of an actual voice. So vocoders are algorithms that convert acoustic features into audible sounds. Basically, vocoders are GAN-based. You know probably what GAN is. They are generative adversarial network in which there is an opposition between a generator and a discriminator. So a generator produces audio and a discriminator evaluates realism. I always tell my students that so as to understand how a generative adversarial network works, you have to imagine it as the competition between someone who is a fake artist, an artist who produces some fakes, a perfect copy of Caravaggio, a perfect copy of Raphael, and so on and so forth. And on the other hand, the discriminator is a detective or an art connoisseur who tries to find out whether a certain painting by Caravaggio is really by Caravaggio or if it is by a fake artist. So there is a competition between the artist who makes fake Caravaggios and the art connoisseur or detective who tries to find out whether a Caravaggio is truthful or is a fake. And GANs work because of the competition between these two agents, between the fake artist and the art connoisseur. So by pitching generator and discriminator one against each other, we have both improving their performances, so that the consequence is that fake becomes more and more performative, more and more resemblant to the authentic specimen, and more it is difficult to realize the difference between a fake voice and the real voice modeling which the fake was created. So now vocoders are models that adopt also patterns of diffusion. You probably know what stable diffusion is in the creation of AI images. So that these are models, diffusion models are models that iteratively refine noise into structured audio through stepwise denoising. So it's exactly the denoising that happens for the creation of images in stable diffusion happens also in the creation of voices in 11 labs or similar algorithms. So these approaches produce high fidelity audio with artifacts that can be considered as endowed with a high level of authenticity, exactly because they follow these probabilistic parameters to sound truthful and to refine more and more the truthfulness of how a voice sounds. Now, vocal optimization. What is vocal optimization? Well, once we have created a voice with a vocoder, we also have to optimize the so-called inference pipelines. So an inference is the process of running a trained model to generate outputs. And also, we have to optimize streaming synthesis, so producing audio progressively rather than waiting for a full sequence. We need these models to be fast and to be performing well, which involve also chunking, so splitting input into smaller segments that are processed sequentially. And also a context window, so a recent history retained to maintain continuity between chunks. Hardware acceleration and model quantization produce this computational overhead. So all these processes are processes of post-production of AI voices that allow AI voices not only to be produced and to be authentic and to be realistic and to be recognizable as the voices of someone in particular, as voice clones, but they allow also the streaming of a voice to be effective in the long term and to be scalable into massive usage. For instance, if we have to use a voice not only to read the sentence but to read the text or to be used in the dialogues of a movie, of course, we need to stream the low latency optimization. 11 Labs in particular supports also multilingual synthesis through unified phonetic modeling. So what happens is that language is tokenized, so that multilingual tokenization, shared representation across languages, allows the same model to be transposed into different languages. And there is a standardized phonetic symbol strategy, which is the one of the International Phonetic Alphabet that is used in order to map the phonemes of different languages and enable cross-language consistency. Traditional linguistics or traditional phonetics did not really work in computational linguistics because voices are now produced mainly through stochastic or probabilistic apparatuses. At the same time, we rely on very traditional phonetic concepts like the International Phonetic Alphabet in order to guide now these new machines, even in their probabilistic processes, to create voices across languages. One aspect to consider is that modern voice AI systems include also safety and ethical safeguards. Very soon, 11 Labs realized that there might have been a problem in the cloning of voices. Cloning is always a problem. It has been forbidden, for instance, as regards the biology of human beings. You remember the sheep called Dolly that was cloned, and that was the object of a perfect clonation. And the international community of scientists then decided that human clonation had to be forbidden. So there is no legal possibility now to perform a human clonation, the clonation of a human being, although, of course, this is technically possible. The same goes for voice cloning. 11 Labs or other companies producing AI voice algorithms, that are produced through generative artificial intelligence realize that could be a danger. And so more and more they embed into their own production modules of speaker verification, so checking whether synthesized voice matches authorized embeddings, watermarking, which is becoming more and more important, so embedding inaudible signals that indicate the synthetic origin. So watermarking is a little bit like a filigrane in traditional money. So it's something that we don't detect immediately when we use money, but at the same time, we can use specific machines to check whether a note is truthful or not. The same goes for the watermarking of AI images or AI sounds. So we can use then artificial intelligence to determine whether the origin of a specific sound or image was synthetic. But also filters that moderate content, and so algorithms that detect harmful or policy violating output. Unfortunately, when 11 Labs first put in the market and for free this algorithm, this powerful algorithm for voice production. One of the first artifacts that was produced, someone used the algorithm to clone the voice of the actress Emma Thompson and had Emma Thompson read Hitler's book, Mein Kampf, in English. So, unfortunately, humanity is able of fantastic behaviors and fantastic, marvelous performances, but also human beings are able of tremendous evil. Therefore, it is very important to safeguard these algorithms and to create sandboxes in which this algorithm can be tested, it can be made safe before they are given to the large audience. And these mechanisms that are now included in AI voice algorithm aim exactly to mitigate misuse such as impersonation or deepfake fraud. Let's keep the technicalities because I want to conclude on voice cloning in particular, and in particular on instant voice cloning, which is a feature that enables rapid synthesis of arbitrary speech in the timbre of a target speaker using minimal reference audio. So it means that I need just a short recording of voice in order to clone that voice and to make it sound very recognizable and believable, authentic. So instant voice cloning is a system that extracts a speaker embedding from a short audio sample and conditions a generative model to reproduce that voice. Hyper-realistic synthesis is then what follows. So it's an audio generation with high perceptual similarity to the source speaker, minimizing detectable artifacts. And this requires minimal enrollment time, so a very short processing elapses before the cloned voice becomes usable. What has enabled this progress is a key technical shift, which is the compression of the voice pipeline into a near frictionless workflow. So we need less than 5 minutes now to clone a voice, drastically lowering the barrier between intent and execution. If I want to clone a voice, now I need 5 minutes to do it, and in the future probably it will be even less. I want to show a little example to you, which is
hey y'all, it's Taylor Swift here. Due to a packaging error, we can't sell 3,000 Le Creuset cookware sets, so I'm giving them away to my loyal fans for free. If you're seeing this ad, you can get a free Le Creuset cookware set today. But just a heads up, there are a few rules. Hey y'all, it's Taylor Swift here. Due to a packaging error, we can't sell 3,000 Le Creuset cookware sets, so I'm giving them away to my loyal fans for free. If you're seeing this ad, you can get a free Le Creuset cookware set today. But just a heads up, there are a few rules. You must live in the United States, and you can only get one free kitchen set per household. All you have to do is click the button below and answer a few questions. These will only be given out until the end of the day today, so don't hesitate. Supplies are running out, so get yours while you can. Thank you guys for all your support, and I hope you love your new cookware set.
Well, of course, you have recognized the most famous singer in the US, but probably also in the world, and is also the most famous female voice at the moment, not only in the US, but globally. And in this video, she's promoting cookware set, which is a very good one. It's by Le Creuset, so it's a French one. You know how expensive they are. But of course, Taylor Swift would never promote cookware sets. She's too busy, creating new songs, performing globally in gigantic concerts. So this is a fake. It is a deep fake that uses not only a face deep fake, so a fake of the video and body of the singer, but also a vocal deep fake. So it produces a fake of the voice of Taylor Swift. And this is at the same time also an ad by McAfee, Maybe you know this company has produced antivirus systems since the 1980s at least. So it's one of the biggest protagonists of antivirus technology in the world. Now McAfee is promoting these particular new device, which is a McAfee Audio Gen I deepfake model. So it is a device, is a software that enables allegedly to recognize whether some parts or the entirety of a vocal audio have been produced through artificial intelligence. So on the right side of the slide of this ad, you see those passages in the audio that go below the threshold of authenticity, so that we hear the voice of Taylor Swift, we recognize the voice of Taylor Swift, but the machine, the device invented by McAfee, also recognizes that in this vocal performance there are moments in which the audio is manifestly fake. We don't realize it, but the machine realizes it. But the question is, do we really need this technical device to recognize whether a voice is cloned or not? Yes, we do. But at the same time, we also need what I would call a new vocal epistemology. So the fact that it is also on the basis of community-based epistemic filtering that fans, for instance, the fans of Taylor Swift rapidly identify synthetic audio as fake. So they don't need McAfee to say, well, this is not Taylor Swift's voice. First of all, because the context is too strange. Taylor Swift would never promote these cookware sets. So it is not part of her image, of her persona. And at the same time, fans, especially young people, are getting more and more accustomed and sensitive to the digital fake. So if I show today some digital deep fakes produced 5 years ago, my current students immediately tell me, oh, but this is a fake, because, you know, the technology advances, but also our ability as human beings to adapt to technology and to be able to be able to say what technology contains in terms of authenticity or fake is also progressing. So as human beings, we also advance and progress in our adaptation to artificial intelligence. And I'm confident that people who will be born surrounded by AI products will be able to tell the difference between an audio that has been produced in the early 2000s by artificial intelligence, 2020 by artificial intelligence, and an audio that will be produced in 2030. So going toward the conclusion, because I prepared too much material and maybe I left to record another audio for Korea University. First of all, let me tell you that it's been a real pleasure talking to you today. But I want to stress the fact that there will be more and more an ethics issue because we'll be surrounded by AI voices. These voices will be generated by artificial intelligence. Some of them will be very useful. They will restore, for instance, the life of those who have lost their voices because of diseases, because of pathologies or accidents. But at the same time, we'll have to preserve the humanity of the voice, because the voice is not a given. It is formed through time, through error, through contingency. So it is a gradual emergence of a expressive identity through iterative practice and failure. We shape our voice as we shape our life, and we learn to recognize the voices of our family members or friends as we learn to love them. So a voice, in a nutshell, is not discovered as a shortcut, but it is created through complexity. It is constituted by dwelling with it. We preserve we cherish, we recognize the voices of the people that we love exactly because we are together with their bodies, with their presence, with their voices, with their affection. So AI voices will multiply in the future, but we'll have to make sure that despite everything, the voice keeps a remaining essential feature of our humanity, of the way in which we interact with each other, of the way in which we build a relation, of the way in which a society is produced and reproduced also through the exchange of not only content, not only messages, not only text, but also the beautiful way in which a human voice can sound. Thank you very much for your attention.